Hi guys, today we are working on solving exponential equations with logarithms. At the beginning of this unit, we started to work on solving exponential equations. So it just means whenever I have a base, we're not dealing with logarithms yet, we were just dealing with exponential equations. And it said that if I had the same base, then I could just set my equations equal to each other. Remember, we're just dealing with exponential. So now we're going to look at if I had different bases. So now when I'm solving exponential equations with different bases, we want to take a common logarithm. We haven't learned about natural logarithms yet, but we're going to want to take a common logarithm, which is our log base 10 of each side. We can use the properties of logarithms, specifically property 5 from our list of properties, to rewrite the exponential problem as a multiplication problem. After changing the problem from an exponential problem to a multiplication problem, using the properties of logarithms, we'll be able to finish the problem. So we're pretty much going to turn it into a multiplication problem instead of exponential. So let's go ahead and look at our steps. So first, we're going to determine if the numbers can be written using the same base. So remember, we were changing our exponents to be the same base. If we cannot do that, remember, like I had 4, and then it was like to the power of x minus 2 equals maybe 8 to the power of x plus 3, something like that. And here we would rewrite our base to have the same base. So I would have put 2 squared, and then I had x minus 2, and I would distribute it, and it'd be equal to 2 cubed times x plus 3. So that's what we did in the very beginning. So just kind of refresher, and we would set those equal to each other. But now we have different bases that can't be rewritten with the same base. So next, we're going to take the common log of the natural log. Like I said, we're not dealing with natural logarithms yet. So we're just going to take the common log of each side. Use the properties of logarithms to rewrite the problem. We're going to rewrite it as a multiplication. So again, you're taking your exponent, we're dealing with our exponents, and we're going to move it to our coefficient, and then we're going to rewrite it just like so. So we're just using our exponent property, power property. Divide each side by the logarithm, and then we're going to use a calculator to find the decimal approximation. So we're going to have definitely decimals. You're definitely going to need your calculator, okay, just to use your logarithm button. And then we're just going to finish by isolating the variable. Okay, so let's try this first example. So here I have a base 5, and here I have a base 18. We know we cannot rewrite 5 to any power to equal 18. So we're going to have to take the logarithm of both sides. So whenever I take the log of 5 to the power of 2x minus 3, and we're going to take the log of 18. Remember, these are both base 10 because this is my common log. And so here I have a power property. So now I need to move this 2x minus 3 as a coefficient to the very front of my problem. And log 5 equals log of 18. Okay, now I'm just going to use my calculator to get some of these calculations. So I'm going to do a log of 5, which gives me, if I plug that into my calculator, this is 2x minus 3 times, it equals 0.69. And then I want to take the log of 18, which equals 1.26 if I round. And then now I'm just going to continue solving. So I would divide by 0.69 by both sides. So 1.26 divided by 0.69 is 1.83. And then I have 2x minus 3. And now we're just going to continue solving. So I would add 3 to both sides, which gives me 4.83 equals 2x. I'm going to divide by 2 on both sides. 4.83 divided by 2, x would equal 2.4 2. And that would be your answer. Make sure you guys are rounding correctly, because in your assignment in Delta Math, it could mess up your answer. But that's how you're going to do it. You're going to turn this into a multiplication problem and then solve. Let's go ahead and try. It says to round our answers 6 decimal places, but I don't think it necessarily needs 6 decimal places. Usually it's to the tenths or the hundredths in Delta Math. Okay, and then the next problem, we're going to do the same thing. There's no power I can raise 7 to equal 512. So we're just going to go ahead and take the log of both sides. So I would do log of 7 times 5x plus 3, or to the power of 5x plus 3, and log of 512. Now we're going to go ahead and rewrite this. We're going to move our exponent to the very front as a multiplication. So 5x plus 3 times log of 7 equals log of 512. You can do it where you take the log of 512 and divide by the log of 7, or you can find your decimals and then do them together. But I'm just going to go ahead and put the log of 512 divided by the log of 7. That gives me 3.205. If I round it, it'd give me 3.21. So, and that's going to equal 5x plus 3. If I subtract 3 from both sides, I get 0.21, and that would equal to 5x. Now I need to divide by my 5 on both sides. 0.21 divided by 5, x would equal 0.042. And that would be my answer. Okay, let's try one more example. Here we're going to take our log of both sides to the power of 2x minus 5 equals the log of 87. Again, we're going to rewrite this with my multiplication in the front, minus 5 times the log of 3 equals log of 87. We're going to divide both sides by the log of 3. So log 87 divided by the log of 3, it would be 4.07 2x minus 5. We're going to add 5 to both sides, so I would get 9.07 2x divided by 2, x equals 4.54. Okay, so that's how you're going to do these problems, exponential equations without the same base. If you guys have questions, please let me know. I feel like it's a very simple lesson, so make sure you reach out to me if you have questions. Otherwise, go ahead and go do the assignment on Delta Math. All right, bye guys.